This is lesson 5.5. We're going to talk about what is a proportion. So notes pages 8 and 9. A proportion is an equation stating that two ratios are equivalent. The products AD and BC are called cross products of the proportion. The cross products in a proportion are equal. So we have this example right here. Cross products are when you multiply across and making that x there. We're going to see this where when we actually do the cross products and they're equal to each other, we're going to end up with having an equation. So in the first one, I'm going to go ahead and multiply 10 times x, which will give me 10x. And on the other side, 4 times 9, which will give me 36. Dropping a line down my equal side, I'm going to divide by 10 on both sides in order to get the x all by itself. And 36 divided by 10 will give me 3.6. In the next example, I'm going to go ahead and multiply across, noticing that this is kind of it has an expression down here, not just a single number or variable. So I'm going to put that in parentheses. Multiplying across is going to look like 2 parentheses x plus 8 equals 6 times 3, which is going to give me 18. Two options that I have here, because this is just plain over on this side, I could go ahead and divide by 2 on both sides and then go ahead and take care of the x plus 8. Or I could go ahead and distribute the 2. Just for the argument here, let's go ahead and actually just divide by 2 on both sides, which will cancel that out, leaving me with x plus 8 equals 9. Subtracting away the 8 on both sides, I'm left with x equals 1. For the next one, multiplying across, 10 times 10 is 100. 8 times n is 8n. I'm going to go ahead and divide by 8 on both sides to get the variable all by itself. And that leaves me with 12.5 equals n. Down here with letter D, again, we see this expression, so we're going to put it in parentheses. Cross product here is going to be 3 parentheses x plus 5, and 5 times 9, which is 45. Just to keep things a little bit easier here and actually shorter steps, we're going to divide by 3, which is going to leave me with x plus 5 equals 15. I'm going to subtract 5 on both sides, which will leave me with a final answer of x equals 10. In letter E, I do see the expression down here. I'm going to use my cross products, 9 times k, k times 9. This is going to be 9k equals 6 times the quantities k minus 7. Here, I can't just divide by 6 because this is not going to easily work with that. So I am going to actually have to distribute my 6 here. So we get 6k minus 42 is equal to 9k. I do typically move my smaller k. Remember, using your steps from the distribute, combine like terms, move your variable, add, subtract, multiply, divide. I would typically move this 6k, but I definitely want to move this one because the 9k is already by itself. So I don't want to move that at all, regardless of what the situation is. 9k minus 6k is 3k. The k's over here have canceled, and I'm left with negative 42. So dividing through by 3, that's going to give me a negative 14 for k. Last example, I notice I have an expression on the top and on the bottom. So I have 9 parentheses p plus 10 is equal to 8 parentheses p minus 7. Again, because I do have this on both sides, I'm going to have to distribute. So I have 9p plus 90 equals 8p minus 56. Moving the smaller variable, so I'm going to move the 8p. 9p minus 8p is going to be 1p, plus the 90 is equal to negative 56. Going ahead and subtracting the 90 on both sides, so I get p is equal to negative 146. That's how you solve proportions. We're going to see a couple examples here of applications on page 9. So the first part, proportion word problems comparing two quantities. So these are basically going to have you write unit rates, but you're going to have to keep your labels so that they're equal on both sides of the proportion, because the proportion is just the two rates that are equal. So it says after 2 hours, the temperature had risen 7 degrees. Use a proportion to find the amount of time it will take at this rate for the temperature to rise an additional 13 degrees. So we have here in 2 hours, the temperature went up by 7 degrees. So I'm going to go ahead and use that to set up the first side of my proportion. My labels here are hours over degrees, so I would recommend that you write hours over degrees on this side as your labels first. We took the number 2, we've used it. We took 7 and we used it. We still have 13 degrees. We want the 13 to match its label, so that's going to go on the bottom. And we're trying to figure out the amount of time, so x hours. When we set this up, then we can use cross products. So 2 times 13 is 26. 7 times x is 7x. Dividing by 7 on both sides, so if I have 26 divided by 7, I get 3.714. We're just going to round to the nearest tenth. Those 3.7 equals x. So we can say 3.7 and x's label is hours. Number 2, a car can drive 30 miles in 45 minutes. How far can it drive in 65 minutes? So that goes together. So we're going to start with this first piece of information, the 30 miles, which happens in 45 minutes. On the other side, we're going to follow the same setup. We have miles over minutes. Noticing I have 65 minutes, that will go in the bottom. And I'll put an X for the miles because it says how far. Cross products here, 30 times 65 is going to give me 1,950. And 45 times x is equal to 45x. Dividing by 45 on both sides, I get x equals 43.3 repeating. So we'll just round off to the 10th place. So 43.3, and my label for x back here in my proportion was miles. So that's how you can compare two different quantities and find one that's missing for a third part. In the word problems using ratios, this is going to be a little bit more complicated. We're going to be looking at part to whole is what we're going to be considering here. So we're going to have to keep that in mind. So number 3, the ratio of type O to non-type O donors at a blood drive was 37 to 43. How many donors would be type O out of 300? So this is a total number of donors. So here we have type O, non-type O. We need to get our total. So if I do 37 plus 43, I end up with 80. So I have 80 total in my ratio that's here, and I'm trying to look at that out of a total of 300. So I want to know type O. So type O came first in my ratio. That was 37. So 37 O, type O people, out of 80 total is equal to how many type O out of 300 total. So again, keeping my labels to be exactly the same here. Cross products here, 37 times 300 is going to give me 11,100 is equal to 80x. So I'm going to divide through by 80. And I'm going to get 138.75 equals x. Reality here is that I do not have a whole extra person. So I only have 138 type O donors. So when we're talking about people, we have to kind of be careful with our rounding because that 0.75 is not going to count for a whole extra person there. So we have to round down in this case. Number 4, the ratio of 7th grade students to 8th grade students in a soccer league is 17 to 23. If there are 200 students in all, how many are in 7th grade? So we want to know 7th grade out of total. So in my ratio, there were 17 7th graders out of, if I have to add these together, so that's going to give me 40 is my total. So I have 17 7th graders out of 40 total. And I need to go ahead and do the same thing. How many 7th graders out of 200 total? So I'm going to look for x here. Cross multiply here. So I'm going to have 3,400 is equal to 40x. And I'm going to go ahead and divide both sides by 40. So I get 85 equals x. So we would say there are 85 7th graders. And that's it for your lesson on solving proportions.